So it's a real simple concept, and I think that most everybody really knows what intersecting lines is, but if you don't, it's really simple. Here's a line. My arm is just one line. It goes on and on forever in two directions. Here's another line over here, okay? If they cross, meaning, not like this where they don't touch each other, but if they actually cross where the lines actually touch each other and they go through, they have this one intersection point here, we say that they intersect, okay? So we're going to see that time and time again in geometry. So what we're going to do is just draw just a little example. Here's a line. This line goes through point C, and this line goes through point D. Okay, so this is some line, right? And we have another line that goes up like this. And this line goes through point A, and this line goes through point B. But you can see right away that this line CD and this line AB, they actually cross each other right here at this point, and we call that the intersection point. We say that these two lines intersect each other, okay? So this point right here is the point of intersection. Okay, this is the point of intersection. And if we were going to write this down like for an answer to a test, we would say that line AB, and we're just going to get a little practice writing down line AB, intersects line CD. So if you remember back to the previous section, the way you write a line is you put the 2 points that the line goes through, and you put this double arrow over the top showing that it goes on and on both directions. So you see, this is a good example. You look at this drawing, and if you're not really familiar with what's going on, you've got these 2 lines, and you've got these 3 points, and you've got this thing here, and this arrow, and everything, and it looks confusing. But when you just break it down, it's super simple. You've got a line, and you've got another line, and all we're saying is that these 2 lines that we write down in this fashion, they intersect each other. It just means they cross each other, okay? So keep that in mind, and we're going to move on to something else that's probably not familiar to most people watching right now, but it's a core section of geometry, and you're just going to see it over and over again. So what we're going to say is we're going to define another term. Here we defined intersection. Now we're going to define something else. We say a line is transversal, and that's the word I'm trying to define here. Transversal, that's a line you're going to have to really learn what that means, okay? That's a word you're going to have to learn the meaning of. Transversal. If it intersects two or more other lines. So let me write that down over here. 2 or more other lines. All right, so now you see, I'm going to go ahead and underline this. I'm going to underline this part in green. 2, whoops, I picked up the wrong color. Well, let's go ahead and do it. 2 or more other lines, okay? So what we're trying to do is we already understand the topic of intersection, okay? And now we're going to further expand that, and we're going to say another kind of line, we call it transversal, if it intersects 2 lines, 2 or more other lines. So now that you know what intersection means, now you can understand the topic of transversal. So how would you draw that down? A picture is worth 1,000 words, okay? Here is a line, and we're just going to call that line A. I'm not going to define the points that the line goes through. I mean, I could do that, but I don't need to do that right now. I'm just going to show you that there is a line here, okay? And here is another line that goes on and on forever like this. And these 2 lines, they never cross each other, okay? You'll learn in a minute when we talk about it a little bit more that we'll say that these 2 lines are parallel. But for now, we'll say that this is line B and this is line A, and they go on and on and on, and they never touch each other. They just go on and on and on, okay? Okay, so now if I take a third line and I go up through here and down through here, and I call this line T, then the bottom line is I say that this line T that goes up and down, I'm going to say that T is transversal, okay? Because it intersects 2 more lines, 2 or more other lines. Now I could have tons of other lines here crisscrossing, but all I need it to do is intersect 2 lines. See here, T intersects A and T intersects B, and it's a simple definition. You don't need to know why that's the case or what does it matter? That is the way it is, okay? So as long as you just remember that, you can apply it in your problems and you'll be good to go, okay? So the way you would write this down is you would say that line, and I'm going to put in quotation marks, line T is transversal. And we're going to see a lot of additional problems like this. So don't feel like you have to really just understand everything based on this one picture. We're going to learn a lot of other stuff here. And then we say here, just to show you, just to close the loop a little bit for you here, line A and line B are not transversal. I'm just going to abbreviate it transversal, okay? The reason line A and B are not transversal is because you look, how many lines does line A intersect? Well, it goes on and on. Okay, I intersect this one line and that's it. But that doesn't make it transversal. A line is only transversal if it intersects two or more other lines. Line A only intersects the one line here, okay? Line B only intersects line T, only one line, so it's not transversal either. Only line T is the one that's transversal because it actually goes and cuts through two other lines, okay? So it's very, very important for you to understand because in your test, they're going to always ask you about transversal lines or they're going to reference transversal. Take a look at the transversal line in this problem. Well, you're going to have to know what that is in order for you to actually have a hope of actually being able to solve it. So let's go ahead and move on to another example, and I think we'll get the hang of this a little bit better. Okay, now what we're going to do is we're going to work an example to kind of show you a little bit more complicated problem dealing with transversal lines, and I think you'll get the hang of it. So let's say we have this problem, okay, on your test or on your homework, and it's just got, again, one of those diagrams that at first looks complicated, but whenever you start to take a look at it, really isn't. There's a line D, okay, it just goes up and down like this, okay, and then we have a line Y that goes on like that, okay? And then right here we have line T, that's a line T, and then over here we're going to have another line, and we're going to call that line R, okay? So we're going to ask ourselves a few questions here. The first question is D transversal? All I'm saying, I'm writing down a question for myself here, just like you might see on your test. Is the line D transversal? Okay, the other question is, does D actually go through and hit two or more, does it intersect two or more other lines? That's all you have to do to ask yourself to answer this question. Does it intersect two or more other lines? Well, D goes down, down, down. Well, it hits Y here, so that's one line, and then it keeps on going, and then it hits R. So it definitely hits two or more other lines, so the answer is yes. It is transversal. Okay. Is Y transversal? Okay, let's look at what Y does. Y starts here and it goes on, so it definitely hits a line here. It hits T, right? And then it goes on, and then it hits R. So it definitely hits two or more other lines. So yes, Y is transversal. So let's look at T. Is T transversal? Okay, so we look at T. T goes up here, right? And you see it intersects. Now this is kind of tricky, and that's exactly why I picked this, okay? Because T goes up, and you can see that all of these three lines, this one, and this one, they all hit each other at one point, okay? And when you're talking about a transversal line, I said it has to intersect two or more other lines, but kind of implied in that, it can't intersect them all at the same exact point, okay? So you see right here, Y goes like this, and D comes like this, and exactly at the point that they cross, T intersects it. So at first, you might think, well, it crosses the line Y, and it crosses the line D, so it crosses two lines, so I'm going to put a yes here. But in fact, the answer is no, because the reason I chose this is to show you that in order for a line to be transversal, it has to cross two lines, but at different points. You see, R is transversal, and we're going to get to that here in a minute. Let's just go to that now. Is R transversal? And I think I'd already just said the answer. The answer is yes, it is, because R hits this line here, D, and it goes up and it hits this line, Y. So yes. So now let me just step back and talk about this a little bit more. T is not transversal because although it does cross the line Y, and although it does cross the line D, it crosses them at exactly the same spot. So the definition of transversal wasn't written down, but it really implies that it has to cross those lines at two different points. So really, it has to look something like this, where you're crossing a line and you go up a little bit more and you cross another line. So that's exactly why I chose that problem there. Okay, now we're going to talk about another term dealing with lines that intersect each other. It's very important, and I know you've heard this. Almost everyone's heard this term. It's called perpendicular. Two lines are perpendicular in a big picture sense when they cross each other at 90 degrees. That's really all it means. You have a line here, you have a line here, and the two lines must cross exactly perpendicular to one another. There's no angle here. I mean, you're not crossing at an angle like this. You're crossing exactly up and down to the other line. That makes a 90-degree angle there, 90-degree angle there, and so that makes it perpendicular. So to write this down in terms so that you can study, two lines are perpendicular, and by the way, you're going to see this time and time again. That is the symbol for being perpendicular, and we'll talk about why in a second. If they cross or intersect, which is the same thing, at exactly 90 degrees. That's exactly what the definition means, okay? So just to give you a picture, we always like pictures, okay? Here is a line X, okay? And here is a line Y. This looks like your XY plane from algebra, doesn't it? Okay, and if you put that symbol right here, this means 90 degrees. That's exactly what that perpendicular symbol means. It means 90 degrees, and so that means line Y and line X cross at 90 degrees, and that means that they are perpendicular with one another, okay? So really, you know, these two lines here, okay? This angle here is not 90, this angle is not 90, so those lines are not perpendicular, right? You know, these two lines are not perpendicular. The only time you're going to have perpendicular lines is if the lines cross exactly up, you know, exactly so that one line just kind of runs broadside into the other, and it's going to make a 90-degree angle. That is why the symbol looks like this. So you will see this all the time. Now, also, don't get confused if you see something, you know, like this. Like if you have a line like this and a line like this. Well, you may look at this initially and you may say, well, those aren't perpendicular. It doesn't look like this. But you really have to look here at the angles. You know, all you've done is take this and kind of twist it and rotate it a little bit. If you have a 90-degree angle here, if this line crosses exactly broadside to the other line, giving you that 90-degree angle right here, then those lines are going to be perpendicular, okay? Those lines are going to be perpendicular. So let's go ahead and work a little bit more complicated example, just to give you practice dealing with how to identify perpendicular lines, and then I think it'll become even that much better. So let's say you have a line here, and we're going to call that line B, and you have a line here, and we're going to call that C, and you have a line here, and you call that line A. Okay? And in the problem, I give you this little square there, and that tells you that's a 90-degree angle here and a 90-degree angle here. And what I want to point out here is to tell you that in this case, A is perpendicular to B, and A is perpendicular to C. So A can be perpendicular to more than one line for sure. But in this case, line A is also transversal because it cuts through two different lines. It intersects line B and it intersects line C. So you would write that down. You would say line A is perpendicular, that's the perpendicular, to line B and line C. And you would also say line A is transversal. And you can abbreviate that trans, or you can write it out transversal. So there's two different things that apply here. A is perpendicular to B, A is perpendicular to C, and A is also transversal. So another way you would say this is you would say line A is perpendicular to B. Line A is perpendicular to see. This is the symbol for perpendicular there, and that's why I was showing you that above. So you'll see there's a lot in your problems. You'll see that they'll put that down. They'll say A is perpendicular to B, or A is perpendicular to F, or something, and that'll tell you that the angle between these two lines is exactly 90 degrees. So half the challenge in solving your geometry problems really isn't doing any math or any complicated algebra. It's just simply understanding what it means when they say perpendicular or transversal. And that way, when you understand the relationships, you'll know right away this means 90 degrees between A and B, and now you have a number you can work with. A lot of times you'll be calculating the angle of something, and you'll need to know what the angle is between two lines, and that's going to tell you that. Okay. So what we're going to do next is we're going to move on to the sister term of perpendicular, and that's the concept of being parallel. I know that all of you have probably heard the term parallel before, and again, I'm going to write it down on the board, but before I get there, perpendicular we just talked about was when two lines cross at exactly 90 degrees, up and down, left and right like this, okay? Parallel means that the two lines never cross, and they're parallel with one another, okay, and they go on and on and on, parallel with one another, on and on, but they never cross each other. That's what parallel means. Parallel just means two lines go on and on right next to each other. They never get closer together. They never get farther apart. They're exactly parallel to one another, and they go on and on just like regular lines do forever. Okay, so let's write that down in words. Two lines are parallel, okay, parallel, and this is the term I'm defining, so I'm going to underline that. And by the way, the symbol for parallel lines is two lines like this. They're at a little bit of a slant. It's like an equal sign, kind of tilted. This means that the two lines are parallel. They never touch each other. Okay, so they're very descriptive. If they are in the same plane, and I'll explain that in a second, in the same plane, I'll explain that in a moment, and they never intersect, and they never intersect, which means they never cross, right? All right, now what does this mean here, okay? If they're in the same plane and they never intersect. Now the never intersect part is exactly what I told you already before when I put my hands here. They never intersect, they never cross. So all I really need to do is explain the first part. So let me draw a little plane here and see if I can make you understand why that first part's important to say. There's a little plane. Remember, a plane is just like a sheet of paper. There's no thickness to it. I'm just drawing it on the board. It looks like a little rectangle that's tilted over. But in reality, what I'm drawing is a flat surface like this piece of paper. That is a plane, okay? And on this sheet of paper, I'm drawing two lines. So you got to imagine, you got to use your imagination here. I'm drawing two lines on the surface of this sheet of paper, but I'm just writing on the board like this. This line is line A, and this line, we're going to say that it's parallel to line A, is line B, okay? Now, we're going to say that these two lines are parallel to one another, and to show that in the drawing, okay, the way you do it in your geometry book is they put a little triangle shaded on both lines. So I'm trying to teach you the terminology, and I'm trying to show you what you're going to see in your books. Because again, it all comes down to just understanding what the terminology is, okay? So we say that line A is parallel to line B. We're using our symbol here. Parallel. Line A is parallel to line B. It's a very simple concept. It just means there's two lines and they're set up so that they just go on and on forever and they never cross, okay? And these two triangles mean that line A is parallel to line B. It means the same thing as here. So if they never told you this, if that was not given in the drawing, these triangles would be all you would need to show you that these two triangles are parallel, that these two lines are parallel to one another, okay? Now, let me see if I can explain why they have to be in the same plane, okay? I'm going to have to use my hands here, okay? If the definition only said that they never intersect, okay, that wouldn't be enough to say that they're parallel, okay? Because let's think about three-dimensional space. We're not talking about the sheet of paper here. We're talking about here. Let's talk about three-dimensional space. Let's say this is a line, my arm and this marker. That's a line that goes up like this, okay? Now, let's say I have another line, which is my other hand, right? And that one is just like this, Okay, so I'm drawing it like this. It looks like these two lines cross, right? But let me just kind of rotate my body and show you they never cross. They never cross. But these two lines are not parallel, because the definition of parallel really means that they go on and on together in the same direction, parallel to one another, okay? And they never cross. So if you just put two random lines together that never cross, I mean, these two lines never cross. I mean, you can see these two lines will never cross. This one's going to go over this one, but they're not parallel because they're not going the same direction. But if you confine the lines to the surface of a plane like this, and now if you say you have two lines that never cross, that means they have to point the same direction. Okay, and you have to kind of get a piece of paper out to figure that out, I think, for yourself, to kind of play with it a little bit. But the only way, if you confine these two lines to the same plane, that they can never cross, is for them to be parallel and go on together forever and ever, like that. Okay, so two lines are parallel if they're in the same plane and never intersect. Okay, because you can find plenty of lines that never intersect in three-dimensional space, like this one and this one. They're never going to intersect, but they sure don't go in the same direction. So we need them to go in the same direction to be parallel. Okay? Let's do another little example showing parallel lines and giving you some practice in figuring out what, how to pick them out of a drawing. Okay? A little bit more complicated. Let's say here you have a line, and that's going to be, again, line A. And here you have another line, and here's going to be line B. We're going to say these two lines are parallel. We'll get to it in a minute here, though. Now, since they're parallel, I'm going to put a little triangle here to show you that, right? These two triangles mean, look at me, I'm parallel to him. I never cross him, but I go off in the same direction, okay? So what this really means over here is that line A is parallel with line B. That's what the two lines mean. A is parallel to B. It just means they never cross. That's all it means. They never cross each other, and they're in the same plane. Now, let's make it a little more complicated, and let's draw another line that goes like this, right? And we'll call him C. And let's draw another line like this, and let's call him D. Now, I'm going to tell you right now that C is parallel to D. I'm drawing it that way to show you that. Of course, this is not a very good line down here, but they're supposed to be parallel to one another exactly, so they never cross. So you can see it would be pretty confusing if I just put a set of triangles here like this, right? Because I know that A and B are parallel, but if I put these here, I'm trying to say C and D are parallel, but I'm using the same triangle as I'm using down here, so it's going to be really hard for me to know, which ones are parallel. So if I have another set of lines that's parallel, I'd use two sets of triangles. That's all I have to do. Okay, so now you can immediately look and you can see these two lines are parallel because I have one triangle, and these two lines are parallel because I have two triangles. I'm just teaching you a little bit of notation here. That's all this is. This is just saying that when you have two lines in a drawing that are parallel, you put one triangle. And if you have another pair of lines that are also parallel, you just put two triangles. You're going to see that all the time. And all this is really telling you, without writing it out, without actually saying anything, is C is parallel to D. Okay, that's exactly what it's saying. So C is parallel to D, A is parallel to B, and if you want to go back and look at some other terms that we've learned, C is also transversal because it crosses A and it crosses B. It crosses two lines. D is transversal because it crosses A and B. A is transversal because it crosses C and D, and B is transversal because it crosses C and D. So it turns out that all four lines in this drawing are transversal lines. Okay. And by the way, this drawing here that has the two lines like this and the two lines like this, you're gonna see this a lot. Okay, the two lines with the transversal down. That's why we're introducing it and going over it in such detail, because a lot of the problems in geometry, at least in the beginning, a lot of them are going to actually have drawings that look exactly like this. So what I'm trying to do is I'm trying to break the ice a little bit and get you comfortable looking at those types of drawings, so that whenever we get to the problems that we're going to get to here in just a minute in the next section, that drawing that can look kind of complicated at first, you become familiar with it. Okay, so let's do that. So let's talk about the next topic, related, but the next topic, and we're going to call that interior and exterior angles. Okay, this is something we're going to learn about over and over again. Let's say you have a line, and we're going to call that line L. I can call the line anything I want, so I choose to call it L. And here I have another line. This line's parallel. Okay, so that line's M. And because they're parallel, we already just learned in the last little part there that all I have to do is put a triangle to show you that it's parallel. That's all I have to do. And that triangle just tells me that L is parallel to M. That's all it tells me. Those two triangles right there. So they never cross. That's all it's telling me. Okay? Now, I draw a transversal. The transversal crosses two lines, remember, two or more lines. So I draw a transversal and I just call it T, T for transversal. Okay? Now, notice that when I do this, I create a lot of angles here. I create an angle here, 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 another angle here, 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 and here. And it turns out that for whatever reason, the geometry books and the classes and the lessons, they focus on this a lot. Okay, this drawing here that has the two parallel lines and the one transversal. You'll be asked so many times to identify angles in a drawing that looks exactly like this. So let's go and tackle it. Let's call this angle angle 1, this one angle 2, this one angle 3, and this one angle 4. I'm just labeling them only so that I can reference them later. There's nothing special about these numbers. I'm just putting them there so I can reference them. This one will be number 5, 6, 7, and 8. Okay, so there's 8 angles. We already just talked about that. Okay, now let me go ahead and erase this because I'm going to write some stuff over here that's actually pretty important. Okay, pretty important. I'm going to write it down on the board and then I'm going to explain it. So don't feel like you have to understand it the first time I say something. Angles, and notice I'm using the kind of the abbreviation for angles. 3, 4, 5, and 6. Angles 3, 4, 5, and 6, right? They are called interior angles. Okay, they're called interior angles. And angles 1, 2, 7, and 8, they are called 1, 2, 7, and 8. They are called exterior angles. Right? Now remember, this is only a definition, okay? This actually doesn't have anything to do with math. This is just teaching you the terms so that you can follow along and do the problems, okay? I've told you that they focus a lot on this type of problem with a transversal cutting down. You make 8 angles here, and it's just a label. 3, 4, 5, and 6. These are the interior angles because they are interior to these two parallel lines. Okay, that's all it means. They are the ones inside the two parallel lines, so we call them interior angles. Interior angles. And I guess you could figure out now that 1, 2, 7, and 8 are called the exterior angles because they are on the outside or the exterior of these two parallel lines. Okay, that's all it really means. Interior and exterior. Okay, now this is important, so I'm going to kind of box it in, and I'm going to continue defining some other angles. And eventually, when I'm done with this whole thing, you might want to pause the video and just study it a little bit. But really, it makes sense. These are exterior, and these guys in the middle are interior. Now, these are a little bit maybe not quite so easy to understand. Okay, angle 3 and angle 5. Which are these, angle 3 and 5, they have a special name, and they are called alternate interior angles. Okay, alternate interior angles. So you see what we've done is we've defined the interior angles here, and now I'm just telling you that these two are drawn opposite sides or alternate sides of this transversal. These two here, they're alternate interior angles. So they are a subtype of the interior angles. Here, these are all the angles that are interior. All I'm saying is that these two are alternate because they're on alternate sides of this transversal. That's all I'm saying here. And likewise, angles angle 4 and angle 6, Same thing. I'm just going to write it down again. Alternate interior angles. Okay, so all I'm saying is that here we have the set of interior angles, and here on the opposite sides of this transversal we have alternate interior angles, 3 and 5, and 4 and 6 are also alternate interior angles. Okay, 3 and 6 are not alternate. There's nothing alternate about them because they're on the same side of this line. Okay, so I haven't talked about those yet. But these here, 3 and 5 and 4 and 6, these pairs of angles, they're called alternate interior angles. Okay, so what I'm going to do now is I'm going to circle that because that's important. I want to leave that on the board. I'm going to come back and I'm going to talk about that a little bit later. And the next thing I want to talk about are, what do you think these two angles would be called? These types of interior angles, 3 and 6 and 4 and 5. Well, they're not alternate interior angles because alternate implies they're on the opposite sides of this transversal. So we just call those, plain and simply, same side interior angles. So I'm going to say angle 3 and angle 6, angle 3 and angle 6, I'm going to say that they are same side interior angles. Okay. 3 and 6 are same side interior angles, and the same thing with 4 and 5. So angles 4 and angle 5, and you've got the same thing here. Same side interior angles. Okay, so we've defined a lot of stuff here. So I've kind of boxed them in, and they're terms. This is exactly the kind of problem you would see on a test. They would draw this, and they would say, well, what type of angles are angles 1 and 2? Or whatever, 4 and 6. And you would have to say, are they same side alternate? Are they same side interior? Are they interior? Are they exterior? What do they mean? If you just think about the terms, it can become clear. You know they're interior angles because they're interior to these lines. 5 and 3 are alternate because they're on opposite sides of these lines. 4 and 6 are also alternate because they're alternate sides of these lines here. And here are the same side angles because they're on the same side of this transversal, and the same thing here, 4 and 5. And then these guys on the outside, they're just called exterior angles. Okay, now we're going to use the same exact drawing that we had before. There's nothing different. We got the 2 parallel lines, L and M, and the 1 transversal, and the 8 angles that are formed. And now we're going to talk about corresponding angles. Corresponding angles. Okay, that's what we're going to talk about next. Okay. It's very simply, corresponding angles are angles in the corresponding positions, okay? So you can see that 1 is in the corresponding position as 5, 2 is in the corresponding position as 6, 3 with 7, 4 with 8. That's all it means, okay? You look at the top set of angles and you find the angle that's in the corresponding position as the one on the bottom, and those are your corresponding angles. So you say angle 1 and angle 5. Okay, those are corresponding. All right, angle 3 and angle 7. Those are corresponding because those are on the same exact location, but just being, rather than being here, it's down here. Angle 4 and 8. Okay, angle 4 and 8, and angle 2 and 6. And in all these cases, they're all corresponding angles, okay? So 1 and 5, 3 and 7, 4 and 8, and 2 and 6, and that's all it means. So the question on the test might be, find the corresponding angle to angle 2. Or maybe they'll change it up and they'll put a letter here, and this will be called A. And you'll say, what's the corresponding angle to angle A? And you'll just have to look down here and say, well, it's this one right here, and you write that down as your answer. Okay, now in the final part of this section of the class, we're going to talk a little bit about theorems and postulates, and then we're going to have some example problems, okay? Lots of words that fly around in geometry that are frightening at first and that don't really make a lot of sense, but I'm going to try to explain them to you so that, they become a little bit more familiar to you so that when you work your problems in your homework, they're not so much of a big deal, okay? So what is a postulate? Okay, a postulate is just simply a statement of fact. That's all it is. You're not proving anything here. You're not saying, you're not trying to prove that this is true. You're just saying it is true. It's like a statement of fact would be, in the human species, there are males and there are females. I mean, you could sort of prove it by going out and rounding up all of the humans and making sure that there's only 2 different kinds of us out there, okay? But it's really more of a statement of fact. There's nothing to prove about it. There's nothing to mathematically show your work and figure out why that's true. That's just something that's true. There are males and there are females. That's true, okay? Or humans have 2 eyes. Well, that's a statement of fact. That is nothing to prove, okay? A theorem, on the other hand, which you'll see all throughout your geometry books, a theorem can be proved. And what I mean by that is it can be proved using the mathematical tricks in your toolbox. It can be proved using your postulates, your axioms, and your other things that are sort of your statement of facts. And you'll build upon logically the progression of logic, and you can end up proving these theorems. So the theorems are true as well. I mean, there's no distinction. I mean, the theorems are true and the postulates are true. It's just that the theorems are kind of higher level things, okay, that can be proved. Okay. So what we want to do is I want to give you a couple of examples of what a theorem is in comparison to what a postulate is, so that you can kind of get the hang of it. Okay, here's a postulate. Okay, here's a postulate. If 2 parallel, I'm using the symbol for parallel, lines are cut by a transversal, and I'm going to abbreviate that transversal, then the corresponding angles are congruent. And remember, congruent just means equal. Congruent just simply means equal. Okay? So this is a postulate. Okay? This is a statement of fact. Okay? Now, let me go ahead and remind you of what we're talking about here. Here's 2 parallel lines. And here's a transversal that cuts them. All this thing says, and you have to get good at reading the math and just trying to figure out what it means. If you don't do that, you'll never get anywhere. You have to read it slowly and you have to understand each and every word. So let's do that right now. If 2 parallel lines, these are the 2 parallel lines, are cut by a transversal, this is cut by a transversal, then, so this is the then part, then the corresponding angles, which we just defined, the corresponding angles are like this one and this one, or like this one and this one. It's just the ones that look the same in the top and the bottom. The corresponding angles are congruent. So for instance, that would mean angle 1 is congruent with, or let's just say angle A is congruent with angle B, okay? And that is a statement of fact. There's nothing to prove there. That just means that if you draw this on your paper and you measure this angle and you measure this angle, they are in fact exactly equal. It's the same thing as the, or very similar to the vertical angle theorem that we had before, the vertical angles, where you had 2 intersecting lines and we said these vertical angles were congruent or equal, and that was just something that's just true. Well, it's the same thing here. You have corresponding angles and you cut it like this, and the reason that they're equal really is because these 2 lines are parallel, so for all practical purposes they point in exactly the same direction. So when you cut them, by definition you're cutting them both in exactly the same way, in exactly the same angle. So these corresponding angles have to be equal, and these corresponding angles here and here have to be equal. And that's exactly what this postulate says, okay? So here is a theorem. Here is a theorem, which is also true, but it's a little bit more provable than the postulate here. And we're going to deal with this drawing here, okay? If 2 parallel lines are cut by a transversal, okay, then, this is the then part, this is what you're looking for, is then, whatever follows must be true. Then, alternate interior angles are congruent. which just means they're equal, okay? Okay, so let's go back to our drawing. Let's figure out what that one means. We'll take this off. Okay, so I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8. Okay, what are the alternate interior angles first of all? Well, these are the interior angles. The alternates are 5 and 3 and 4 and 6. And you can kind of see just by looking at the drawing that this angle, which is kind of big here, looks about the same as the angle 5. Okay, so this would be an example of this would be angle 3 and angle 5. They are congruent. Okay, angle 3 and 5 are congruent. 4 and 6, you can kind of see that they look similar too. They are also congruent. Angle 4 and angle 6. They are also congruent. 4 and 6. That is a theorem. You can prove that, you know, and some books have the proof for that, but the proof of it really isn't that important. The main thing I want you to do is learn that it's true, because you're going to have to learn that over and over again. So what I'm telling you is when you have a drawing like this, parallel lines cut by a transversal, these alternate interior angles, they're equal. And these alternate interior angles, they are equal as well. Okay? And you can kind of see that even by just drawing. So if you totally forget which ones are equal, you know, you can kind of just draw some parallel lines and you can say, well, this one is, you know, the same as that one, and this one is roughly the same as that one. You have to be careful doing that because, you know, you're not really drawing it to scale, but I think if you do it carefully, you'll get the point, okay? One final theorem, that they all have to deal with these angles here. So I'm putting them all together. So, same thing. If two parallel lines cut by a transversal, okay, then the same side interior angles, then, and this one's a little bit different, same side interior angles are supplementary. And remember, supplementary just means they add up to 180 degrees. So supplementary. Supplementary just means they add up to 180 degrees. Now let's look at this. First of all, if two lines are cut by a transversal, which is what we have drawn here, then the same side interior angles, which are like this one, 3 and 6, or 4 and 5, same side interior angles are supplementary. That just means they add up to 180 degrees. And you can kind of think through that logically because, you know, we already said these corresponding angles, 2 and 6, they're actually equal to each other, right? So if you just look at these two up here, 2 and 3, this is a line, which is a straight angle. Remember, 180 degrees straight angle is just a line that goes like this, and it's cut. And so this angle 2 plus this angle 3 must add to 180 degrees because I've got a straight angle here. 180 degrees by definition goes like this. But since 2 is the corresponding angle to 6, which means these two are equal, and we just learned that here, the corresponding angles are congruent, which means this is congruent with this, then angle 3 and angle 6, when you add them together, must be equal to 180 degrees. Because angle 2 plus 3 must be 180, and these two are actually the same angle. It's just in a different place. So 3 plus 6, angle 3 plus 6 must be 180, and by definition 4 plus 5 must be the same thing. So to show you that kind of in words, what you would say is you would say angle 3 plus angle 6 equals 180 degrees. And you could say the same thing, 4 plus 5 is equal to 180 degrees. Okay, now the last thing we're going to do is we're going to work a big example. So what we want to do here is we want to do two things. First, we're going to write down the name of the angle. Name of the angle. I'm going to draw a picture here in a minute. And then we're going to write down if it's congruent or supplementary. Okay, congruent or supplementary. And I'm going to draw the picture over here. Same thing as always. I've got two parallel lines. See, all these problems end up being the same. This is line C, this is line D. Now I'm going to draw a transversal here. Okay, obviously C is parallel to D, right? And I'm going to label this 1, 2. Well, first I need to draw my other line here. this is a little bit more of a complicated problem, so I've got two lines that go off like this that are transversal lines, okay? I'm going to call this line A and this line B, okay? And this line is parallel with this line. So that's all that this is telling you. These two never cross and these two never cross, but they're both transversal to the other two lines, okay? So this is angle 1, angle 2. I'm just labeling now. Angle 3, angle 4, angle 5, angle 6, angle 7, angle 8, angle 9, 10, 11, 12, 13, 14, 15, and 16. And the only reason I'm doing that is just so I can reference them. There's nothing magic about these numbers. I'm just drawing a little bit more complicated picture. I mean, this is what we've been working with all along. I'm just making it a little bit more complicated. So, problem 1, angle 1 and angle 9. First thing I want to know are what type of angle is it, and are they congruent or supplementary? So angle 1 with angle 9. Well, you see, this angle and this angle are in the same position on top and bottom, so they are corresponding angles. So I'll put that they're corresponding angles. Okay, and I'm just abbreviating that. Now the next question is, are they congruent or supplementary? Congruent just means are they equal, or are they supplementary, which means they add to 180? Well, you can kind of tell right away that they are congruent or they're equal just by the way it's drawn, but you also remember back from the theorem actually says that corresponding angles are congruent, which means they're equal. So they're congruent. Okay? Next problem. So these two were corresponding angles, and because of that, they were congruent. They were equal to one another. Okay. Angle 7 and angle 11. Here's angle 7, here's angle 11. What kind of angle are there? Well, they're both interior angles because they're interior to these two lines, and they're on the same side of the transversal here, so they're same side interior angles. So they're same side interior. Okay, now from your theorem back in the previous section, same side interior angles are supplementary, which means they add up to 180 degrees. So they're supplementary. These two angles you can kind of see. This is a little bit smaller than this one, and also you can kind of think 11 and 3 are equal to each other because they're corresponding angles, and 3 plus 7 must be 180 because this is a 180 degree angle, straight angle here. So if these guys are actually similar angles there, then this one plus this one must also be equal to 180, okay? Because if these two added together must be 180, and if these two are equal, then these two added together must be 180. I'm going through a lot of extra logic to show you what I'm trying to say, which is the easiest thing I'm trying to say here, is that you need to look at your theorems and sort of memorize them. But if you forget how to memorize them, then that's how you can figure out the answer. So they're supplementary. Okay, now the next one is angle 5 and angle 10. Okay, so let's look at those. Angle 5 and angle 10. What kind of angle are there? Well, they're interior angles because they're interior to these two parallel lines, but they're on alternate sides of this transversal. So they are alternate interior angles. Alternate interior. Okay, alternate interior angles. And if you look back at your theorems, and also you could just look at the drawing here, this and this, they have to be congruent angles, okay? Alternate interior angles are congruent. So these guys are congruent, which just means they're equal. And you can kind of see that here. You can see that right here. These guys, by definition, when you cut a line through two parallel lines like that, this angle right here and this angle here, you can just sort of see, and if you measure with a protractor, you'll see that they're equal. So alternate interior angles are always congruent. Okay, well, let's just do another one here, and that'll be 9 and 11. Angle 9 and angle 11. Angle 9 and angle 11. What kind of angle is that? Well, at first that's a little confusing because you're looking top and bottom here to try to figure out your patterns. But notice that if you just turn your head 90 degrees here and look at it this way, these two angles are, what are they? They are corresponding angles. Because all that corresponding angles mean is that they're in the same place in both kind of sections of the drawing here. So if you look kind of to the side, this is on top here and off to the right of this transversal, and this is on top and off to the right of the transversal. So they're in the same place, and corresponding angles are always congruent. That's just a fact. Corresponding angles are always congruent. And you can kind of see that. This angle looks about the same as that one. Okay, so the final one we'll do is 11 and 14. 11 and 14. Here's 11 and here's 14. Again, it looks a little bit funny because you're used to looking up and down, but if you look side and side, 11 and 14, they're on alternate sides of this transversal, right? And they're interior because they're interior to these two lines, so they are alternate interior angles. Alternate interior angles. And if you look back at your theorems, alternate interior angles are always congruent. Alternate interior angles are always congruent. And you can see this angle looks about the same as this angle right here. So I've tried to give you kind of a flavoring of the types of problems you can expect to see that are drawn like this. A lot of them are. You really need to go back to the theorems that I presented and any other theorems that might be in your book and really memorize them. But I want you to do more than memorize them. Understand what they sort of mean. I mean, when you look at it, all they really are saying, you know, there's just a couple of them here. They're saying that corresponding angles here in the same location here, they're congruent, they're equal to each other. They're also saying that alternate interior angles like these two here, they're congruent to each other, okay? And they're also saying that same side interior angles are supplementary, which just means they add up to 180 degrees. Now, to prove that, I mean, you can go off and do some other stuff, but the bottom line is that that's fact, and you just kind of have to memorize that and remember that. And those facts are going to be what's going to allow you to take a look at these angles and figure out what types of angles they are and if they're congruent or not. And also, it's good practice because geometry is full of theorems, and you really just have to understand those theorems and be able to apply them, and you will do well now and as you move forward.
Learn anything at mathandscience.com.